Hi guys, once more welcome back to my mathematics tutorial. My name is Peter C. Junior, your math tutor, and I am an instructor of mathematics at the University of Liberia. In today's lesson, we want to look at finding derivatives of trigonometric inverse function using trigonometric substitution method. So in previous lesson, we saw a few other problems under this substitution method. We want to look at question number 27 under finding derivatives of trigonometric inverse function of which substitution method is a part. Now, again, as a reminder, whenever you have a trig inverse function and you want to apply the trig substitution method, you must first have an understanding of the trigonometric identities to know which of the substitution to employ. So we have 1 divide 2x squared minus 1. 2x squared minus 1. What is it? 2x squared minus 1. So if we look in the denominator, 2x squared minus 1. This seems to be cos of 2x because we had cos of 2x, which was cos square x minus sin square x. So if we replace this sin square x with 1 minus cos square x, which is the Pythagorean identity, it means this negative will make this one negative and make this one positive. So you will have cos of 2x now to just be equal to cos square x plus cos square x is 2 cos square x minus 1. So we clearly see that this identity down here, this expression down here resembles this identity, such that if we just make x to be equal to cos of x or cos of some theta or whatever the case might be, then it means that we will have 2 cos of theta all square minus 1. So that's why I say you must know the trigonometric identity so that you know which substitution to employ. So we have let x equals cos of theta. So we can solve for this theta by taking cos inverse on both sides. So cos inverse of x is just equals to theta. So let's keep this theta right here. Cos inverse of x. Let's erase this so that we get more space. So go back to the problem. Y equals to secant inverse of 1 all over 2. Now the x now is cos of theta, but since x is squared, so we square cos of theta minus 1. Now 2 cos squared theta minus 1 is just, this is just equal to cos of 2 theta. But now there is an important identity that we need to remember, the reciprocal identity. Now we know that secant is equal to, secant of theta is equal to 1 all over cos of theta. So it means if you have 1 all over cos of 2 theta, this will be equal to secant of 2 theta. So y equals to secant inverse of secant of 2 theta. So y now will be 2 theta, because secant inverse of secant of 2 theta is just 2 theta. So let's find our derivative, but we need to know first what is theta, like we found in the initial stage. So we have 2 cos inverse of x. So y prime now will just be the derivative of this function, which is minus 2, because we know that the derivative of cos inverse of x is just minus 1 all over the square root of 1 minus x squared times the derivative of x, which is just 1. So final answer will just be negative 2 all over the square root of 1 minus x squared. So this is our final answer for this problem. So thanks ever so much for watching. See you in our next lesson. Thank you.